Okay, so in this example, we're going to look at radioactive decay and half-life. So what we're asked for is, what is the half-life specified in days of a radioactive sample with this many atoms, 5.0 times 10 to the 15 atoms, and an activity of 5.0 times 10 to the 8 becquerels. Okay, so first of all, this number is telling us the number of decays every second. So this is, you can call that R. So that's the activity. So this is R, and that's the activity. Activity is decays per second. Okay. So our R value is going to be this dN by dt. It's the amount of change in the number of these atoms as they're decaying in a period of time. We looked at that when we were talking about the equations that we use for decay, and we said, well, that's equal to the rate of decay times the amount of atoms. And we also want to recall that R is equal to 1 over tau, which is the lifetime. Okay, so we've got this R value, and that's equal to, well, we can write it as N over tau. Okay, because we know that we've been given that R value. And what we actually want is half-life. And we actually have a relationship between tau and the half-life, which we looked at previously. So we worked out that tau is also equal to half-life divided by ln 2. Or, another way of looking at it was half-life is equal to ln 2 tau. These are equivalent. Okay, so coming back to here, we've got a R value then that we can say is ln 2 over our half-life times our N, so our number of atoms. So now we've got what we want in terms of a couple things that we already have. So let's rearrange for what we want, which is our half-life. So our half-life is going to be equal to, we've got ln 2, and then our N value, which we were given as 5.0 times 10 to the 15 atoms, some radioactive material, and then that's all going to be over our R value, which is 5.0, numbers are going to work out nicely there, times 10 to the 8 becquerel. Okay, so that is going to give us a half-life, and that works out to 6.93 times 10 to the 6 seconds. Great, except that's not the units that we were asked for. So let's just convert this to what we want, which is days. And the way that I do that is I work with watching the units, so seconds. I want to cancel seconds. And so let's go up to, well, 1 minute is 60 seconds. So these will cancel. And then 1 hour gives me 60 minutes. So these will cancel. And then 1 day, which is the unit we're looking for, has 24 hours. So these units cancel. So now we're in the units that we want, and we work that out, and we get a T1 half, or half-life, of effectively 80 days. It's 80.2, but significant digits here are, just got that, so it's 80 days. Okay, so we have a half-life of 80 days.